Hey Evan, so I'm going to go over your final and answer the questions that you missed. I've got it copied into a Word document here. As I go through the questions, make sure you're maybe taking notes, following along, and then once you've watched this video, I will reset the test for you. So the first question you missed was number 3. It was solving the system using elimination. So when you solve using elimination, you're trying to get the same coefficient. Whoops, I'm going to X. You're trying to get the same coefficient in front of either the x or the y. It doesn't matter which one. Sometimes one's easier than the other, so that they will cancel each other out, which means they have to have opposite signs. So 7 doesn't go into 10 and 3 doesn't go into 8, so you can multiply either the top or the bottom, or excuse me, you can either get rid of x or y. I'm going to get rid of y here because 3 and 8 are smaller than 10 and 70. So I'm going to multiply the top equation by 8. That's going to give me a negative 24y here. I'm going to multiply the bottom by negative 3 because I need to get a positive 24y there. So it's going to give me negative 80x minus 24y equals, and then make sure that you are multiplying all the way across, negative 144. In the bottom it's 21x plus 24y equals negative 33. That variable is going to cancel out because a negative 24 and a positive 24y, that would be 0y. So now we have negative 80 plus 21, that's negative 59x. You have negative 144 and negative 33, that's negative 177. Now we divide by negative 59 to figure out what the x is, and x equals 3. So when I go over to my answers, I can see there's only one ordered pair that has a 3 in the x position, so I know that that's going to be the right answer. If there was more than one, I would have to plug this x back into the original equation and solve it for y. So if you go back to the top equation, negative 10 times 3 minus 3y equals negative 18. So that's negative 30 minus 3y equals negative 18. Add 30 to both sides. Negative 3y equals 12. Divide by negative 3. And you can see we get y equals negative 4. Now, because it's multiple choice, you don't actually have to solve it using elimination. You could just take those ordered pairs and start plugging them in. So you would plug like negative 4 in for x here, and you would plug 3 in for the y, and see if you get negative 18. You would also have to plug in negative 4 here and 3 here, and make sure you get 11. You could do that for all 4 ordered pairs, and then your answer is the ordered pair that solves both equations. One of these ordered pairs, it might work in one equation but not the other, but it has to work in both in order to solve the system. Okay, next was number 5. These are not easy. So it says at 9 o'clock on Saturday morning, 2 bicyclists heading in opposite directions pass each other on a bike path. So I'm going to put their point. This is where they pass. We have one, we'll just actually write north and south. We have one heading north, 5 miles per hour faster than the one heading south. At 10:45, they're 47.25 kilometers apart. Find their 2 rates. So the bicyclist heading south has the slower rate, so we're going to call that R. And the bicyclist heading north has the faster rate, that's going to be R plus 5. What we need to remember is the formula distance equals rate times time. And the distance that they travel, 47.25, that's total distance for both of them, 47.25 kilometers. That means if you add the distance that each one of them travels, so we'll just call them north and south, the north distance plus the south distance has to equal 47.25. But all we have are their rates, so we're also going to use time because distance equals rate times time. So the north bicyclist, after an hour and 45 minutes, and we need to convert that to minutes, 45 is 3/4 of an hour. Excuse me, we need to convert it to hours. 45 is 3/4 of an hour. So that's so from 9 to to 10:45 is 1.75 hours. Make sure you get how I did that. So 9 to 10 is an hour, and 45 minutes is 3/4 of an hour. So we want to take the distance for both bicyclists and add it together. So the north bicyclist, it's time, 1.75, times the rate, r plus 5. And the south bicyclist, again, it's the time times the rate, and that one was just r, and it's going to equal 47.25. And I hope I've saved myself enough room here. Looks like I have. So we need to distribute 1.75 r plus 1.75 times 5 is 8.75. Bring down the second 1.75 r, and it equals 47.25. Okay, then we're going to combine like terms. That's 3.5r plus 8.75 equals 47.25. Subtract 8.75 from both sides. We get 3.5r equals 47.25 minus 8.75 is 38.5. 38.5. Now when we divide by 3.5, we get r equals 11. So now we have to figure out what does that mean. You'll notice we have to go back up to our picture. That was the bicyclist heading south. So if the rate was 11 for the bicyclist heading south, then the rate for the bicyclist heading north is 11 plus 5, which is 16. And you see that that was the fourth option there. You picked option number 2, but if the first bicyclist is 5 kilometers per hour faster, and you picked the one that shows 14 and 7, that's 7 kilometers per hour faster. So I'm not sure if we were just guessing, but there is quite a process to solving an equation like this. And again, this one is a little different than two cars that leave at the same time and head the same direction. So there's two different problems. You can be going in opposite directions, or you can both be going the same direction where one of you leaves later than the other. Okay, we got 6 right. We missed number 7. So you'll see like a red X above the number, and then I'm just going to keep scrolling until I find the question. So name the set of numbers or sets of numbers to which -1/2 belongs. -1/2 is a fraction, and so the only place where fractions belong, and these are fractions that have been reduced, that's still fractions, is just rational numbers. An integer are all the positive and negative whole numbers. So the integers are like -2, -7, -15, +2, +10, +20, +1,000. So they have to be whole numbers to be an integer, and 1/2 is not a whole number. Next it says you drop a ball from a height of 1.5 meters. Each curved path has 75% of the height of the previous path. So first you have to write the rule for the sequence. Excuse me. The initial height is given by the term n-1, or n equals 1. And what height will the ball be at the top of the 6th path? So what you're doing is trying to figure out how high the ball is going to be basically the 6th time you go through this. So the difference between the two equations is the 150 meters and the 1.5. So, and it is not tricky, but you just had to pay attention to units. So you were given meters, which is what you used, but it was talking about centimeters. So to get from meters to centimeters, we have to multiply by 100. So that's how they got 150. So you probably would have gotten that question right. You just missed that minor detail about the units. 10, 11, and 12 are all good. 13. You have $45 to spend at the music store. Each cassette tape costs $5. So cassette tapes, which it says use X for, cassette tapes are $5. And CDs cost $12. I want to know how long they wrote this problem, because I don't think anybody's buying a cassette tape anymore. I don't even know if people buy CDs anymore. 12Y, and you have $45 to spend. So it looks again just like you just mixed up the variables. So the tape, let X represent the number of tapes. Tapes are 5, and y is the number of CDs. CDs are y's, and you can't go over $45, so it has to be less than or equal to 45. It looks like you just mixed up the variables. Okay, number 19 says to evaluate, so we're plugging in negative 7.2 into what's already a negative x. So my assumption here is going to be that you subtracted instead of adding, so I'll show you the difference. If x is already negative, I'm plugging a negative number in. You're like taking the negative of a negative, and that in turn will make it positive. It's kind of like doing same change change, or multiplying two negatives together. You can think of this as being, let me erase those plus signs. You can think of this as being a negative 1 in front of that x. So if I multiply negative 1 times negative 7.2, we're going to get positive 7.2. So adding those two together gives you 11.1. Okay, 27 asks about the graphs of the lines, are they parallel? So when we look at parallel lines will have the exact same slope. Parallel lines have, what? I'm not even spelling right. Have same slope. Well, the first equation's all set up for us. The slope in the first equation is a 5. Remember, in slope-intercept form, y equals mx plus b, this is your slope. The problem, though, is that the second equation isn't in slope-intercept form, and we need to get it in slope-intercept form so that we can compare the two slopes. So we're going to write the equation. The first thing you do when you're trying to get an equation into this form from standard form, you have to move the x term to the other side. So we're going to add 18x to both sides. I always teach students to put the x term first because it's mx plus b. Okay, the x term comes first, so squeeze that 18x up in front of that negative 54. Now we're going to divide everything by 3. And I'm not even going to completely solve this because after I do 18 divided by 3 and get 6x, I can see that I have a slope of 6 for the second line that I'm comparing to the slope of 5. So since the slopes are different, the lines can't be parallel. You picked one about y-intercepts. It actually doesn't matter what y-intercepts are. Y-intercepts will be completely different for parallel lines, and it doesn't matter that they're different. It doesn't also matter if they're the same. If they're the same, it's the same line. Okay, solution to the system. Again, this one is set up, but it's probably a little bit easier to do substitution. That method should have been taught, but you again could just plug in ordered pairs. Plug in 0.2 right here at x and plug in 0.2 down here at x. Do you get negative 7.6 for both of them? If you do, it's right. You're not going to because it wasn't the right answer, but you also can do substitution. So substitution means take this part and plug it up here for y. If two things are both equal to y, then they're actually both equal to each other. So I end up with 2x minus 8 equals negative 3x plus 7. Remember, this is substitution. I substituted something that equaled y in one equation in for y in the other equation. The one I did at the very beginning, that was elimination. So I'm going to add 3x to both sides. This allows me to have an equation with one variable, just x, so I can solve that. So 5x equals 15, divide by 5, and we get x equals 3. And again, you'll see there's only one ordered pair that has a 3 in the x spot, in the x coordinate, so that is the right answer. I could plug this 3 back in up here to show you that I can get negative 2 for the y. You don't have to do that here because they're only giving you one answer where x is 3. Oh, I love these. Okay, simplify. This is the exponent lesson or unit. Exponents are so fun. So, or at least I think so, but I'm weird. I'm a math teacher. 3x divided by y raised to the negative third power. That means that everything in here is being raised to the negative third power. So let's rewrite that. 3 to the negative 3. X to the negative 3 all over y to the negative 3. Now I teach students this. Remember that anytime you have a negative exponent, things have to flip. So that has to go to the denominator, this has to go to the denominator, and this has to go to the numerator. So basically, we're taking the reciprocal of this, and everything then becomes positive. So now we have y to the third, 3 to the third, x to the third, 3 to the third, 3 times 3 times 3, that's 27. What the heck? Y to the third, 27x to the third, which is that last option there. So everything gets the negative 3. That makes everything have to flip around or switch spots. Okay, solve the equation. 11 equals negative d plus 15. The first thing you want to do is move the constant away from the variable. 11 minus 15 is negative 4. Here's the tricky part, and you might have missed this. That's a negative in front of the d. That's the same as having a negative 1. So if you divide both sides by negative 1 to get rid of that negative variable, you're now going to have positive 4. 34 wants to know if it's linear. So in a linear function, the x's and the y's have to change. So we're adding 2, we're adding 2, we're adding 2. Over here we're adding 4, we're adding 4, we're adding 4. The x's have to change by the same constant, and the y's have to change by the same constant. This is linear. They don't have to both be the same. So x's can add 2 and 4, and y's can add 4, and that's okay. So then the question is, what's the equation? How are we getting from x to y? That's what we really have to focus on. And this can be tricky because it's a lot of guessing and checking. So if you have your x value of negative 7, how do I get to negative 5? Well, I could add 12, right? But adding 12 is not how I get from negative 5 to 9. It's not how I get from negative 3 to 13 or from negative 1 to 7. So adding 12 to x won't work. The question is, what does work? Well, here's what's great. This is multiple choice. So if we look at, not the second to last option, if we look at, and this is going to be kind of hard to see, I'm going to circle this. It's ugly. Y minus 5 equals 2x plus 7. Sometimes this stuff it's tricky to like get it into a Word document. So that's the right answer. There are also y plus 1/2 equals, y plus 7. Sorry, that 1/2 moves up high. Y plus 7, 1/2 x minus 5. Oh, this is point slope form. Cool. No, point slope form. Then the next one was y minus 5 equals negative 1/2 x plus 7. So you can do a lot of things here. You could have guessed and checked. You weren't going to guess and check point slope form, but it's point slope form. That means which point is on the line. The point that's on that line is negative 7, 5. So which one shows negative 7 and a positive 5? Remember though that point slope form y minus y1 equals m times x minus x1. Okay, let's see if you can follow me here. So because the formula has subtraction signs in it, if you plug in a negative number, it's going to make it positive back here at x1. If you plug a positive number in it, it's going to stay looking negative. So signs kind of change in point slope form, or they look like they change. But the point that comes from this line, this first one here where I've got the underlining, is a negative 7 and a positive 5. Okay, that could be the answer. The next one, however, though, this stayed negative and this switched to positive. This is saying that the ordered pair that came from here is 5, negative 7. That's not in that table. That's not going to work. So this one's out. And then the last one, this one again is saying negative 7, positive 5. Okay, that's what we want also. So now it's either the first one or the last one. So it's all about slope. Slope is the y change over the x change. 4 divided by 2 is positive 2. So this one's out now because that one said the slope was negative 1/2. So we're all the way down here on that last option. That's what's great about multiple choice. It's a lot of guessing and checking. Write the slope-intercept form of the equation for the line, and those are impossible to read what happened. Okay, I'm going to have to just do this one, and then you can take my word for it. I don't know, this just really struggled to copy on there. That looks like y equals negative 3/2 x plus 7/8. And it looks like the right answer down here didn't show up, so we'll just solve this one, and then that'll be the right answer. So the first thing you have to focus on in slope-intercept form, y equals mx plus b. You're focusing on the b, right here. That's where the graph crosses, excuse me, where the graph crosses the y-axis. So it looks like it's happening at negative 1.5. So we're going to have y equals, let's keep doing that, y equals something x minus, because it's a negative, 1.5. And I think you can see on some of these it looks like it put it into an improper fraction, which is fine. Now we need the slope. When you calculate the slope, you go from two known points. We count rise over run, and also notice that this line goes in the negative direction, so we know we're going to have negative slope. So starting down here, I go up 1, 2, 3, 4, 5, 6, 7. So we go up 7. Our numerator is 7. We're going to the left. 1, 2, 3, 4, 5, 6, 7, 8. So negative 7/8 is the slope. So again, that was up 7 and over 8. And it's in the negative direction, so I know I need a negative slope. Now we'll just hope that, well, not hope, but that's what this one would have been had we been able to read it. 36 was putting numbers, and I'm going to move this one down to the next page so you can see all 4 options. Putting numbers that are in scientific notation in order. So your answer is incorrect because you have a larger exponent ahead of a smaller one. So the first thing I tell students is put the smaller exponents up front and the bigger exponents in the back, because that number is definitely smaller. If I move this 3 times, I get 5,400. If I move this decimal 4 times, I get 45,000. And so that's definitely bigger. So these two needed to be switched places. After that, if you're looking at numbers that both have the same exponent, then you can compare the actual digit. So compare exponents first, put the exponents in increasing order, then compare the digit in the front of the scientific notation. Okay, that's it. I know this is a super long video, but it's your final exam basically, and so it's a much longer test. If you want to take some notes while you're going over this, some things to help you remember for the next time you take it, that's perfect. This video is going to actually have to go on YouTube, but I'll email the link back in your mom's email, and so you'll be able to watch it through YouTube. If you have any issues though, let me know as soon as possible. Once you've watched the video, let me know, hey, I've watched it, I think I'm ready to retake the final, and then I will reset the test for you.